Welcome back, everyone. So, what we are going to be covering in these next few videos. So, up until this point, we've gone over creating basic toolpaths for 2.5 axes, basic toolpaths for 3 axes. What we're going to do is we're going to go ahead and talk about how we are going to use a custom tool table. So up until this point, we've been using 1 or 2 tools. Now in our lab, we need to set up a tool table, right? We want to have a standard tool index that we can draw from. We're not always going to be relying on just 1 or 2. We're going to be using 2, 3, 4, several tools. I believe this part that we're going to be cutting is going to use about 4 different tools. So what we're going to do is we're going to take our standard mill tool chart that we've been using in the lab, import that into Solidworks, and then use that for cutting. So I'm going to break this into 3 videos. One is just how we're going to go ahead and set up that tool table in Solidworks. The second, we are going to write the programming to cut this part using that tool table. And then this is what we're going to be left with, right? So we're going to go ahead, chuck this up in our mill, and it's going to cut this part out for us. Now this part, we call it a wrench. This is just a representation of a part. It's a pretty good analogous part for other parts that you may want to mill, like race car parts or aircraft parts, right? So we're going to cover how to write the toolpath for this, and then we're going to be left with this pedestal here that we're going to have to remove. Now, the way we would do this would be to flip this part over and chuck it in the mill, and then to go ahead and face this off. Now, the issue we're going to run into is we can't really chuck this effectively in the mill. So what we're going to do is we're going to create a set of soft jaws. Now, in the lab, we've already gone through the beginning part of this. But what we have to do for the soft jaws is machine in a pocket to accept this. That way we're not crimping or deforming this shape at all. So we're going to go over how we generate that pocket and then how we write the programming and how we're going to execute that in the mills. But for right now, let's go ahead and set up the tool table for this. So I'm going to give you guys this part. You can check on Brightspace for this. We're going to go ahead and start this like we normally do. We're going to go to SolidWorks CAM and we're going to define the machine. Now, we're going to come to this screen here. We're going to choose mill inches, and then we're going to go to tool crib. And if you see down here, we should see several tool cribs. Tool crib 1, 2, 3. What we're going to do is we're just going to choose one. Select that. And if you have tools in here, just use the remove tool function to go ahead and remove those. We want a blank tool table. I've got a blank one here, so I'm going to go ahead and do this. Now the tools that we're going to be loading, right? This is from our tool index that we have in the mill. So we've got our face mill, our flat end mills, our drill, countersinking tool, some more drills, and another flat end mill. We're going to go ahead and add these in one at a time. So what we're going to do is we're going to add this 2.5 inch face mill first. So we're going to go to add tool. This is going to pop up with our tool selector. What we want to do is select tool type to face mill. We have a few different options here. We're going to choose the one called 2.5 inch face mill and OK. And that'll pop up here, face mill, 2.5 inches. We're going to repeat this for our next set of, for our full range of tools here. We're next going to load in our 1/2 inch 2 flute end mill, We're going to go to Add Tool. We're going to choose End Mill, Flat End. And this is going to list all of them, right? Right, and pretty much every common size. If you're looking for a specific size, you can filter by diameter and set that to 1/2 inch. And then it will pop up with everything from 1/2 inch on up. Now pay attention to the number of flutes. These are all carbide tools. Like I said in previous videos, that's not going to matter, but we do want to pay attention to the flutes, and we're going to choose the 2 flute option. We've got our second one in there. Next is our 13/64 2 flute end mill. This should be 3/16. So we're going to go ahead and make sure that this is 3/16. Let's see. Add tool. Another flat end mill. We're going to scroll down 3/8. 3/16 2 flute end mill. I'm going to go ahead and click OK. Next is going to be our 1/4 inch drill. By now you guys should understand the process here, so if you guys want to end the video here and just go ahead and add these in, feel free to do so. But I'm going to go ahead and continue on. So we're going to go to 0.25. Quarter inch CNC drill. Our countersink tool. This is that 90-degree countersink. That's also a 1/4 inch. Our 3/16 and 1/2 inch drills. And our last tool, which is going to be that 1/4 inch end mill. Make sure you select the 2 flute option. All right, and here we have our complete tool table. So this mimics exactly what we have in the lab. So this way we know that when we go ahead and generate our tool paths, we have an accompanying tool for that. Now this is important. Make sure you select Use Tool Crib Tools Only. If you don't have this selected, when you go ahead and generate tool paths, it will use the best tool for the job, or what it thinks is the best tool for the job. If you select Use Tool Crib Tools Only, it's going to generate the tool paths using only what we have available. So we want to make sure we have that selected. We're then going to go ahead and save Tool Crib. And we can save this as whatever we feel like saving. Manufacturing 3000 tool crib. And we can go ahead and save that. Now that's going to go ahead and save into our available tool crib. So next time when we go ahead and define machine, we're going to go to tool crib. We're going to select the tool crib that we want and select. and then we can go ahead and click OK. So I'm going to go ahead and end this video here. In the next video, we're going to go through and generate the tool paths to cut this wrench. And then in the video after that, we're going to go ahead and actually generate a set of soft jaws to cut this. But if you guys have any questions in the meantime regarding adding tools or creating your tool crib, go ahead and let me know. Shoot me an email, leave a comment, and we'll get you straightened out. Otherwise, I will see you guys in the next video.